Solving equations, like terms and unknowns on both sides. In an algebraic blank or equation, so that we're talking about either algebraic expressions, so in an algebraic expression or equation, a blank, we're talking about terms, so a term is either a single number or variable, or the product or dividend of several numbers and variables separated from one another from another term by a plus or minus sign. In the blank below, in the equation below, and we know that this is an equation because there's an equal sign. Whenever there's an equal sign, it's an equation. So we're going to write equation here because this whole thing is an equation. In the equation below, let's underline all of the terms. So we're going to underline each term. They're separated by additions or subtractions. Those are the terms. Terms are said to be alike when they are both blank, i.e. numbers with no variable. So if they're both constants, so just numbers, so if they're both constants, which we don't have any constants here. If we had something like this, if this were 4 minus that, and then we had plus 7, then the 7 and the 4 would be constants. So terms are said to be alike when they are both constants, i.e. or numbers with no variable, or they have the same variable or variables raised to the same power or powers. So powers. On the left side of the equal sign, let's circle the like terms. So on the left side, this is an x term, this is an x term, and it's important to note that that is an x term as well. It's got an x, it's divided by 4, but it has the same power, which is really a 1. These all have a power of 1. It's just not written there. So those are the like terms on the left side of the equal sign. And on the right side, we're going to make rectangles around the like terms. So let's see, we have a negative 4x there and a positive 9x there. And those are the only like terms. This one has an x and a y, so it's not like any of the rest. And this is an x squared, and there are no other x squareds here. 7x squared and x squared are like terms, but they're on opposite sides of the equal sign. When like terms are on the same side of the equal sign, we can combine them. When like terms are on opposite sides of the equal sign, we can't combine them, but we can use inverse operations to move them to the same side. So we don't actually move them. It's a little bit different than that, but it's kind of like moving them to the same side. And we'll see what that means in just a moment. So we're going to do some examples here. Everyone makes mistakes, and this is a little correction video that I'm going to replace my original efforts on this problem. So 4x and negative x can be combined together because they're like terms. When we combine them, they are 3x. We have 3x plus 2 is equal to 14. The next step here is to isolate my 3x term by doing the inverse of adding 2. The inverse is subtracting 2. When I subtract 2 from each side, I get 3x is equal to 12. Right here, I'm going to divide by 3 to isolate my x term. And when I do that, I will get x is equal to 4. So 12 divided by 3 is 4. And that is my correction video. And I'm going to switch shirts real quick and go on. On this one, we can combine the 5x. Oh, no, we can't combine anything. There's nothing on the same side that is the same. So we need to move them. So I could move this 5x to the other side, or I could move this 9x to the other side. And the way we do that is we make a 0. I'm going to subtract 5x here. So it makes a 0 on the left-hand side. I'm left with negative 7. 9x minus 5x is 4x, and now I have plus 17. Now I need to get my x term by itself. Here we're adding 17 to it, so I subtract 17 to make a 0. I get negative 24 is equal to 4x. Next, we have 4 times x. The inverse of multiplication is division. And negative 24 divided by 4 is negative 6 is equal to x. So on that one, we had to move our x terms to the same side. On this last one, we're going to have to do sum of both. This is a real long one. So something that's useful here is to note that I can combine the negative 5x and the negative 3x. I can combine the negative 7 and the positive 9. I can combine the 2x with the positive x, and I can combine the negative 8 with the negative 1. Notice I did different numbers of, that should add 4 there, different numbers of underlines to indicate what will be combined. So the negative 5x minus 3x is negative 8x. So I combine the negative 5x with the negative 3. Negative 7 combined with positive 9 is positive 2. 2x combined with positive x is 3x. And negative 8 combined with negative 1 is negative 9. Now I can move my x terms to one side. I'm going to add 8x here. I could have subtracted 3x as well. That would have worked just fine. I'll get 11x right there. On the left-hand side, I get 2. So 2 equals 11x minus 9. I'm going to have to, on this next step, I'm going to add 9. And the result of that is going to go right here. So on the left, we have 11, because 2 plus 9 is the 11. And on the right, we have 11x, and this makes a 0. So 11 equals 11x. Now we're going to divide by 11 because we have 11 times x, and we get x is equal to, well, 11 times 11 divided by 11 is 1. And so our solution is x equals 1. And that is combining like terms and when we have unknowns on both sides.